So what I have today for this portion of the video is the use of sizing heads and support structures and blockers, because both of these are very useful tools when it comes to 3D printing, especially when you're 3D printing helmets. As those of us that cosplay know, and for you just getting into this, you don't ever want to print a helmet that doesn't fit. That's a lot of wasted filament and a lot of wasted time. So I'm going to load the next helmet that I'm using for my project here, which is a Phase 2 Clone Trooper helmet, as I'm looking to make a 501st paint scheme for it. And what I'll go over today is, as I mentioned, the use of sizing heads and support blockers. We'll go over sizing heads first. That'll be kind of a brief major explanation of how they work, what they do, how to get them sized properly, and why I use them. And then on top of that, the second portion will be the support blockers. That'll teach you what the support blockers do and kind of give you an idea of how supports can be used and how they don't need to be used. So what you can see I'm going over here is I'm just quickly looking at these red highlights. I'm just going to point these out now. We'll go in depth to them later. These are the overhanging faces that are necessary to be supported. These are something that the STL file is telling you, hey, this is probably not going to print right if you don't have something underneath it. That's where supports come in, but that in turn is also where support blockers come in. So in this regard, there are definitely some certain things that don't actually need to have blockers put underneath them. That's a pretty standard thing. You'll kind of find it out the more you print and the more you play with it. You'll learn what needs supports, what doesn't. It's just a hit or miss scenario. There will always be something that doesn't necessarily need a support, but that doesn't mean you don't have to put one. The only reason I don't put one is because of the waste of filament they tend to be, but that's a pretty standard notion for most cosplayers to know. So now that we've got an overall look at the helmet, I will put a sizing head into the plane here so you can see why I use these the way I do and what makes them so useful to you. I will link the files for these in the description as they came off a creator from Thingiverse. But what these sizing heads do is basically, as their name implies, they allow you to size the helmet around a typical head measurement. And the nice thing about these four heads this creator has made is that they all use a hat size measurement. So if you don't end up knowing your circumference measurement, there's a super common hat size measurement, because if you have a ball cap, you can find out your hat size. You don't even need to measure, you can just find it out. So on the back of them here, you'll have the long axis at 8.5 inches, the short axis at 6.2. The hat circumference is down at the bottom there at 7 3/8, and the main circumference is 23.2 inches. In the case of my head, I have a 23.5 inch circumference, so that's why I typically will use head number 3, as it's the closest one to my size. Because 23.2, 23.5, they're really not that different, so you don't have to worry too much about making major changes to the size of the helmet or the head. And so why I use these the way that I do is to basically ensure that if I was going to print a helmet that would end up in one piece, I want it to fit me properly. I want it to fit me without having to cut it, having to break it down, having to print it in multiple pieces. I don't want to have to do extra work when I get these helmets made. Truthfully, I really just want to have them fit me from the moment I get them off my printer. Now, that is a luxury I'm sure we would all wish to have. It's not necessarily a realistic expectation, however, when it comes to the world of 3D printing, because there is a crazy amount of issues and unforeseeable problems that will always be a cause when it comes to 3D printing. So I'm going to pull the helmet into the side plane here in a moment, just to make it a little bit easier to work with, because when you work with the helmet in the plane and the head in the plane, it'll often, as you can see, it'll snap them into place. And when I try to pull on the head here, I can't pull it through the bottom of the helmet the way that I need to test the sizing and the fit. After I play with the head a little bit here, what I'm going to end up doing is I'll pull both files out of the build plane, out of that volume, out of that box, so that I can use the control nodes to pull the head to any which angle, any which position that I need it. Because you can see here what it's doing is it's trying to put the head back into the print plane because it thinks I want to print it. I don't want to do that. I just want to use it for a visualization tool. And that's what I'm going to do here. Because once you select the file, you can use it as essentially a teaching tool to show you how would this helmet fit around a human head. Because there's always one thing that is the most difficult when it comes to making a helmet is trying to get it to fit around a human head. It's almost impossible to do on a free scale because when you look at it on your computer, it's not going to be to scale. Therefore, you're going to have problems with the sizing of it. You're probably going to end up with a helmet that you spent 4 days printing not fitting your head, which I've had happen. It's super frustrating, and I wish I knew about this as a tool sooner. So that's why I want to show it to those of you that are hopefully getting into learning this as a hobby so that you know it now and you don't have to struggle with it later. Because what these do is they will show you the pinch points of a helmet. Now, I'd highly suggest just playing around with them a little bit because now I'm going to get into support blockers in the last little stage of this video here, and that's going to be about a 5-10 minute explanation, maybe a little bit less, but it won't be. I'll try to break it down as much as I can. So as I mentioned at the start, all these red highlights, these are portions of the STL that need to be supported because of the way the file prints. 3D print files, they always print from the bottom up. That'll never change. So what you saw here, I just placed one of these little cubes. And one thing I want to point out, as you can see, I'm trying to highlight with my mouse. When you place this cube in the file, it selects both the file and the support blocker cube. That's always something important to remember because what I suggest you do is click the cube itself. Because if you leave it that way, when you go to scale the cube, which I'll do in a moment, you will scale the file as well. And if you've gone through a bunch of calculations to get your right size and you don't have that written down, you can end up with your file being scaled the wrong way for your print. So what I just did here is once you turn off uniform scaling on these things, I recommend doing that with the support blockers, is you can take the scale nodes and you can basically pull them around to size each parameter of it according to how you wish to fill one of these red highlights. And what you want to do is you want to cover these red highlights, but you want to cover them on a 3D plane as well. So you can see why I extended the top of the support blocker out of the helmet. That's why, so that I fill all of that section with the support blocker. And I'm going to do it at the bottom here on these 3 little flutes, and I'll show you why there as well. That's another point I want to get into talking about in the later half of this section. But basically what support blockers do is exactly as their name implies, they block a support from being printed to that piece or to that red section. And you can see on this helmet, there is a lot of supported structures that would need to happen. So that's a lot of filament that you may not want to use because you might look at it as a waste. I know I do. So when you end up slicing it, you'll get your time estimation as I talked about in the previous video, which for this helmet is about 5 days. Your filament estimation for this helmet's about 1,300 or 1,400 grams of filament. That's about a spool and a half, roughly, because they come in 1 kilogram spools. So 1,000 grams of filament, you know that's roughly a full spool. There's always a little bit more, a little bit less sometimes, depends on where you buy the filament from. Now, I use PLA exclusively for most of my prints, and what I'm going to show you when I get this slice finished here in this preview mode, this will show you the physical appearance of what the helmet is going to be printed like. So all these bright red zones, these are the file themselves. These are the walls, infill, and the layers. Now the walls are your retaining strength structure. Your infill is your major strength structure. Your infill will always be attached to the walls, and the layers are built up of both of those, and they work in a sequential vertical position depending on how you print, because they can be printed horizontal too. It just depends on how you slice the file. So all these light blue sections, those are the support structures I mentioned. And as you can see, based on where those red highlights used to be, that's how support structures work. They get built around those red highlights. So as you go down, you see how those support structures would be supporting base layers of the file. And what I'm going to show you here when I get into this side view is why I put the support blockers on those 3 flutes at the left and the right. Because as you see when I pull on the slider on the right, that will move the playhead up and down. So it'll show you how the print would be moving vertically and how it would end up coming off and on the printer. And why I put the support blockers for these 3 flutes is as I gradually increase the layers here, this portion I'm highlighting with my mouse, you'll see that they will build out on top of one another and they don't really have that much overhang. And this is always a risk of something to take. I don't recommend doing this when you're just getting started into printing, but this is something that you can kind of learn to do the more you print and the more you see, because certain levels of overhang won't actually need support. And these are a perfect example of that, because the way they build out and up, they adhere to the pre-existing portion of filament underneath them, as opposed to where you see this neck ring come in, that needs those blue supports because that's about 1.5 inches off my print bed if I had to make an estimate on size. So in that regard, I need to have those supports there because otherwise that neck ring would print wrong every single time I tried this print. And the other cool thing you can do is you can actually see where your print head is. This yellow translucent piece that I've got my mouse around, that is the actual print head of my printer. So what I'm doing here is I'm basically watching a real-time playback of how it would print those layers and those infill lines, as well as the supports. So if you wanted to, you could watch the entire range of all of your print being done. So you can see these green lines here, that is your wall. And the yellow line, that is the base infill layer. So that's what the infill will build off of. The walls will be attached to that. And then the yellow makes the base layer, and that's what moves up every time you gain a layer. Now, in the case of this helmet, I believe there's about 1,800 layers, if I remember from when I sliced it. So, there's a lot of layers. That's why they take so long. But there is a lot of stuff to fill in each of those layers in the same regard. Now, the last little thing I'm going to show you as I move up the helmet here, same in regard to support blockers, is one thing why I don't put support blockers in the center of the helmet. This is something that I learned throughout printing all of my helmets. I've probably printed about 10 or 12 helmets total. Some worked, some didn't. But one thing I learned is when you get up to the top dome here, and you can see it as I move this playhead, is the dome will close itself off in the same regard of what I talked about on the flutes down below. Basically, the top of the helmet will build itself together until it gets to the top of the dome. Once it reaches that point, it'll essentially close itself off without having to support those layers because they gradually move their way in. Now, the one downside that you might find is you'll get a little bit of stringing, but it's nothing major. So once your printer is done, you'll use your little scraper tool to take the prints off the bed. And the next step's going to be to pull your support structure off, which once you play around with them enough, you can usually get them to the point like this where you can just pull them off by hand, unless you need your pliers. So the next step is going to be, if you get your helmet off, great. If it doesn't come off in one piece, then you got a little more work to do. In my case, I had a little bit of a snag, and my helmet didn't come off in one piece. Although that gives me an option to show you a very good technique that I would highly recommend using, and it's one that I wish I knew prior to starting my cosplay journey, and that is called plastic welding. And plastic welding is used to melt the pieces together. I'll show you, you'll see a little bit on a physical side here, because what I have is the pieces of my helmet that I'm working on right now. But like I said, this gives me the option to show you plastic welding, and it's a really good resource that I highly recommend that you learn. So it's one I'm going to show you now so you don't have to struggle with it later. So basically what plastic welding is using a soldering iron to melt the plastic together. It's a really simple technique overall, and it doesn't take a lot of skill to do, and you get better at it as you move along. So the best type of soldering iron to use is one like this. It's a pen style. It's got 2 different heat settings on it. Now, don't ever touch these things. I've burned myself enough times during this to know you don't ever want to get burnt by these. They go really hot. They're very uncomfortable when you burn yourself. Now, the important thing to remember when you're going to do plastic welding is to make sure your pieces are aligned, because having your pieces aligned is going to save you so much time and trouble later on down the road, as you can kind of see what I'm doing off screen here. That's why I have this clamp mounted. So what I'm going to put together here for this portion is going to be the dome. This will be a little bit easier for me to start with, and I can build the rest of the helmet from there. And what I'm going to try and do my best to show you here is how to get these things to not necessarily line up, because that'll be more on yourself when you get to the point of doing it. You can always use a clamp like I tried, but basically what you want to do is you don't want to go too far into it when you start the weld. You want to do something small like what I'm going to do at the crest of the dome here. Basically all you're looking to do is hold the piece in place so you can move to another portion and have it welded after the fact, because I highly recommend you don't go too far into welding one piece or you'll end up with a lot of fixing. So after you finish plastic welding, this is what half of the helmet would look like when it's put together. The rest of it I have printing off to the side. And what I'll show you in the next video will be the starting process for sanding, filling, and priming these helmets, because that will end up being the point you take the most on. Is you need to find all the imperfections, you need to prep them, you need to get them ready for painting. So that'll be what I go over in the next video. Overall, that's all for today. I hope this helped you. and I hope it gets you started towards making cosplays like mine, and honestly joining one of the best hobbies that you could ever hope to have.